Hi guys, got a little something different today. We're going to machine a spider from my lathe. Quite frequently I buy stock in 3-foot lengths. It's convenient to get it from Enco or any of these online suppliers like that. When it's on sale, I usually get some stuff from Enco. But in any case, it has to stick out the end of the lathe because the headstock's only like 15 inches long. And it can get kind of dangerous with the smaller diameters, sticking out here, 1.5 foot. They can get to whipping around if the only place that's holding them is at the chuck. So I'm going to show you what I have done in the past and why that doesn't work, and then we'll get to cutting some metal here. Okay, so here's the situation here. If you want to turn something longer than the headstock, it's going to stick out the end there, and the only place it's really supported is at the jaws. The whole rest of this thing is hanging out there in space, suspended in the center of the headstock. For something like this, it isn't too bad. I mean, I could probably run this the way it is, but you get down to like a 3/8 inch or a 1/4 inch rod, this thing is going to whip around like crazy. I mean, you can kind of see it moving now. And that's just me wiggling it. So, there's some moment there. So this lathe originally came with somebody had drilled 3 holes for screws, and they work pretty good, but the problem is that you can't close the door after you tighten it, and you can't tighten the screws when the door's shut. So you're forced to have this little hook here, and I'm forced to run this lathe with the door open like this when I'm turning stuff, and I don't like that. There's no reason for that. So what I'm going to do is I'm going to turn an outboard spider here that screws onto this thread, okay, and it's going to be outside the door so that I can tighten it with the door shut. And most likely it'll probably just live on there. But this is a metric thread right here. And hang on a sec, let me change some stuff here. Okay, so first thing we have to do is determine what this thread is, and I know it's metric, and I've gone through and checked my little thread check gauges, and it is 1.5. And now what I want to do is I want to measure the diameter here, because this is the root diameter, and that'll tell me how big to make the bore. And then what we're going to do is we're going to take it off. I got a piece of 4140. I think it's 2.5 inches, which is a little big for this. I would have preferred 2-inch, but that's all I have. And we'll bore it. We'll thread it inside with metric, which is going to involve changing some of these gears, so we'll show you that. And then we'll put it on the rotary table and drill 3 holes 120 degrees apart and thread them, and she'll be done. So yep, here we go. Okay, so I set up the steady, and one of the things I did was I cut a groove right here for the rollers to run in. I got my ball bearing rollers in there instead of the bronze tips. And the reason I got this set up like this is because I don't want to waste any of this stuff, so I'll just cut it, you know, I'll do it right all off the end here. You know, this won't fit through my headstock, so this is the only real way to do it other than just cutting off a hunk and throwing it in there, and then you'd be wasting it. So I'm going to do it this way. I'll face it off, center drill it, and then we'll start boring it. Alright, ready to go here. Got some new inserts. I put a new insert in. This is a TCMT 16T304SN from ISCAR, and TCMT 3-1-SM IC3028. And I found that these work really good on alloy steel. I got some other grade of carbide, came from Interstate, and man, this stuff, if you try cutting alloy with that, it just busts. It fractures. So let's get turning this thing and get going here. Feed here. Let's try that. Oh, isn't that pretty? That's a nice respectable center. You know, I've been thinking about this. I think what I'm going to do is turn the OD first while I get the center in there. And then we'll bore it. Just makes good machining sense. We backed off the wheels, and we can turn it a little faster now that we're not riding in the steady. So let's find a suitable candidate. Yeah, this looks like a victim. Try about 600. So I did have a mark on here where I wanted to stop, so let me just get that thing lined up. We are getting the veritable stringy bastards here. This is kind of brutal. Alloy steel's tough, man. Instead of breaking, it just bends around the chip breaker. Well, here we go again. Yeehaw! I think that's a little too aggressive for my poor little lathe. Yep, just a lot of tool chatter. See if we can turn it down. I think we're putting this rest back on. That's a little better. up a little, and I'm going to put the friggin' suck pump on because I'm friggin' choking here. Okay, so we're turning at 300 RPM, 6.5 thou per rev. Here we go. You know, the solution to this would be to turn it faster, but I really don't want to with it in the steady like this. So I guess we'll just have to live with this chip thing. I'm getting much less flex now too. That barely made a scratch. These are 20 thousandths cuts I'm taking here. Up to 30,000 steps of cut, 6.5 thou per rev, 300 RPM, and now we're getting some decent chips. It's cutting good, it's leaving a good finish. Got a long way to go, but we'll get there. Okay, so I got the OD down to size here. So now we're going to start drilling and boring. Okay, so we got our usual 8/8 here for our taper shank drills. The overall length of this thing is just over 2 inches, so we're going to go in like 2 1/4 just to give us some parting off distance there. And we got our little depth gauge there that we can tell what's going on. Okay, here we go, some big hole threading. Use my juice. Use my juice for this. 50 RPM.